In part 2 of this series, we're going to look at the basics of building up a Grasshopper definition. So we're going to model something with Grasshopper, and in the process, we'll kind of see a little bit more about how Grasshopper's interface works and some of the ins and outs. So as I mentioned in part 1, Grasshopper components are a lot like Rhino commands in that each one is kind of responsible for a single action or thing that you would do in a model. So let's actually start by building the thing that we want to build in Grasshopper in Rhino first, just so we can kind of think about the logic of it. So I'm going to hide all of this geometry, and I'm going to turn on my grid. And what I would like to build is a little hexagonal aperture. So I'm going to make a polygon, and I'm going to make sure it has 6 sides. I'm going to locate it right at the center. So when it asks me for the center of the inscribed polygon, I'm going to place this at the origin. In Rhino, if you just type 0 when you're asked for a point, it'll create the origin for you. Nice little trick. I'm going to set the length here to be, I don't know, just about this big. And then I'm going to make another polygon with the same number of sides, also at the origin. And I'm going to make this one a little smaller. And this one, I'm going to move up in space. So I'm going to turn on my gumball, and I'm going to move this up. And what I want to do is basically build a surface or a poly surface that spans this and leaves a hole where the smaller one is. So I'm going to do this with a loft in Rhino. And this is basically what we're going to set to build. It looks like a little geometric barnacle or something. But we'll see how building it in Grasshopper gives us a ton of flexibility. Now, I'll say this, building just this one time, it'll be much faster to do in Rhino. But when you build it in Grasshopper, you have an almost infinite amount of control over how you do this. How many sides does it have? How high is it? How big is the aperture? And you can continue to reevaluate decisions that you've already made. Working in Rhino is a very kind of linear process where it's this step, then this step, then this step. The beauty of Grasshopper is that it allows you to leave certain parts of the process as unknowns or make a provisional decision and keep moving forward and then go back and reevaluate that earlier decision without losing any time or losing any work. So if I decided that I wanted to make this 7-sided, I'd basically have to delete the whole thing and start again. Whereas with Grasshopper, switching from 6 to 7 sides should be trivial. So let's actually see how we do this. So I'm going to type Grasshopper to launch the Grasshopper window. And I'm basically going to follow the process that I followed in Rhino. And this is a good way, especially when you're getting started, to think. It's just like, well, what sequence of commands did I need to do in Rhino in order to achieve the same thing? So I'm going to start with polygon. And I can go looking for polygon. There's probably good reason to believe that it lives under the curve tab, and in fact it does, under curve primitive polygon. But a good tip, and one that I use quite a lot when I'm using Grasshopper, is that I will go searching for something by double-clicking the canvas and typing the name of the thing that I want. In a way, this is kind of akin to the Rhino command line, in that you just sort of, if I don't know the exact name of the command, but I know it's something like, split, mesh, but it's actually, this one, it'll give me some hints about a close match, and that'll give me an idea of what's the thing that I'm looking for, as well as kind of informing me about what are some of the other things that are out there. So I might see a command that I've never noticed before and try it anyway, just to kind of see how it works. And the same goes for this search toolbar. So when I type polygon, I can see everything that's related to a polygon that I might use. You might see slightly different things in your menu because I have some plugins installed which might add additional functionality, but often the closest match is the first one. And you really can't hurt anything by placing a different component. If I placed this one and decided that it wasn't the one that I wanted, there's nothing wrong with just deleting it and adding another one or trying a different one. So let's go ahead and use the base one, the one under curve, primitive polygon. And one thing to note is that right away, it's already created some geometry. Now, the polygon command wanted to know a few pieces of information. Where is the center? How big is it? How many sides? And things like that. Many components in Grasshopper come preloaded with default values for all of their inputs, which is equivalent to, when I type polygon, you'll see that it actually has numsides equals 6, which is whatever the last value I used was. And in general, Rhino ships with some default values for these things, so you don't always have to supply the information that it needs. And Grasshopper works the same way. And we can see what these defaults are by hovering over each input. So P is the polygon base plane, and it already has a one locally defined value, which is the world XY plane, which is basically the origin. This is like this point at 0, 0, 0. It has a radius of 3, and who knows why the default is 3. You probably don't want it to be 3, but at least you see something by having some default value supplied. The number of segments is 6. We can control this. And the fillet radius will even allow us to round this if we wanted to. So we can play with that a little bit later. So I have created a polygon. This actually looks pretty good to me, but I might want to control its inputs. So in this case, let's control its radius. And I'm going to do this with a slider. I could right-click and say set number to be 4 if I knew that I wanted it to be bigger. And I can hit enter to cause that to accept. Or I can create a slider that will hook into this, like we saw in part 1, to dynamically control the variable. One good rule of thumb is that if you know something is likely to change, it's useful to create a slider so that you can kind of explore that possibility. But if you're sure that you want it to be 6-sided and you don't want that to change, then there's no reason to create a slider for that because it's not meant to be treated as a variable piece of information. So at this point, we don't actually know what we want to be, constant and what we want to vary as we do some design exploration. So let's create a slider for the radius and maybe for the number of sides as well. So I'm going to grab a slider from params input number slider. And like we saw last time, I'm going to right-click it and choose edit and set the max value to something like 10. This will be for our radius. And I'm also going to create a slider for the number of sides. And I'm going to right-click. And let's say this, we shouldn't have a value of 0. 0 sides makes no sense. In fact, 1 side makes no sense. 1 side makes no sense. And 2 sides makes no sense. So the minimum of this should probably be 3. It's hard to imagine a polygon with fewer than 3 sides. And the maximum, let's just make it 10, although we could certainly do more. The other thing we'll want to change here, and this is largely a stylistic preference, because you'll notice if I click OK, I can specify 5.9 sides. And what's going to happen here? Sometimes data that gets passed into a component will get transformed automatically. So if I hover over S, you can see that it's interpreting this 5.9 as 6. It's rounding for me because this input expects an integer. That's why that little black hexagon shows a 7. Whereas this one just expects a number, which is why it shows 0.1. So you can see where I in that little tooltip in the upper left corner. But in this case, if you supply the wrong kind of thing, if it can, Grasshopper will usually try and convert it to the right kind of thing automatically. But in this case, it might be useful to just say, we really only care about whole numbers of sides. So let's change this to an integer slider by clicking this N and click OK. And now we'll actually see the values that we care about, which are like, how many sides are there? So let's leave this at 6. Let's leave this one at 6.5. And then, like we did in Rhino, we're going to create a second polygon, and then we're going to move it up in space, and then we're going to loft the two together. So how do we do that? We already know how to create a polygon. We could search for polygon, or we can just take this whole arrangement and copy paste it. So I can go edit, copy, and edit, paste, or I can just use the keyboard shortcuts, Control-C and Control-V. And now I have a second polygon, and if I control this radius, I can make it the smaller one. But one thing that I know is that I don't want there to be 4 sides on the inside and 6 sides on the outside. I mean, maybe you do. If you do, fine, keep it. But I think it probably makes sense in order to guarantee that we can make a nice straight loft, that these should have the same number of sides. So in fact, I don't want 2 segment sliders. I really want 1. So it's useful as you start building up definitions to think about this. Like if there's a piece of number that or a number or a piece of information that needs to be the same in one place as in another, then it's useful to share that actual data between 2 parts of your definition, 2 components. So in this case, I'm actually going to delete the second segment slider with the delete key, and I'm going to wire up the segment slider that I already have, and this has the effect of basically synchronizing this. So however many sides the big one has, the small one has as well, and this will produce a nice clean loft. So the next thing we're going to do is move the small one up in space. And so how do we move something in Grasshopper? We could supply a different base point. So we could create a point that has a z coordinate that's above 0. But in this case, let's actually transform something we've already created so we build up something a little more complex. If I know I want to move something, my first gut instinct when I'm learning Grasshopper is to double-click and type move and see if there are any operations that correspond to the thing that I'm looking for. And in this case, there is one called move. Now, if I would like to learn where this lives in the interface, once I've placed it, I can click Control-Alt, and then click on the component, and it will actually take me to the place in the component toolbar where this component came from. So in the future, if I wanted, I could just go to Transform, Euclidean, and Move, and find that component, and it'll be the same thing. But I find that just searching for it is often more useful anyway. Sometimes it's useful to kind of click around and see what's available in each of these sections, especially when you're getting started. But for practical purposes, I almost never grab a component from up top. Instead, I'm almost always just searching for it with the search. So what does move want? It's good to get in the habit, every time you place a command, to go what I call read that component. You actually try and understand what it needs and what it makes and what it does. So to find out what it does, you hover over it. It says this translates or moves an object along a vector, and it needs a piece of geometry called the base geometry and a translation vector of type vector. We'll talk about vectors here in a second. What it produces or outputs is the translated geometry and a piece of transformation data, which for now we don't need to worry about. So it's useful to get in the habit of kind of reading what you get, because often components will have multiple outputs. Like, I don't know, just looking at this, whether this is the polygon or this is the polygon. When I hover over it, I can see that actually the second output of the polygon component is its length, not the geometry. So we are going to use this output when we want to move something. So I'm going to take this geometry, I'm going to highlight it, select it on the canvas, and select it and turn it green in the Rhino view to make sure that I've got the right one. And I'm going to click and drag from this little circle into this one to wire it together. And you'll see that it already moves it. And in fact, we can see it's moved it up in the Z. It's moved it up probably farther than we want. And the reason that this happened already is that, like Polygon, Move has default values for some of its inputs. It doesn't have a default geometry, which is why this, doesn't produce anything until we feed something in. But it does have a default translation vector, which is from 0, 0, 10. So you maybe are already familiar with the concept of a vector. It's represented a lot like a point. It's an x, y, and z coordinate. But it's very important to know that vectors do not have a location in space. So what do I mean by that? They're often represented in various kinds of diagrams as an arrow, because they basically represent the difference between one position and another. So if I create this line and I say add arrowhead, or just arrowhead in Rhino over here, I can think of this as representing a vector. But the thing that's important to know is that this vector is the exact same as this vector or this vector or this vector. I couldn't say that about a point. This point and this point and this point are not the same, but this vector and this vector are absolutely the same because they represent the difference between what we call the tail and the head of the vector. So this represents like a displacement in space. And it's like if you were to take some piece of geometry in Rhino and say extrude, and it's going to want a distance and a direction. And I can say set base point over here and do my extrusion from here, from here to here. Let's try that again. Set base point from here, and then I'm going to extrude along here. Oh, it's locking to something. But in any case, we'll set our direction to be here, and then we can set our distance. So basically, it's this idea that we're just sort of arbitrarily representing this displacement, but it can affect something wherever it is. It doesn't actually matter, like where it doesn't have a position in space. It's sort of an abstract concept. So, to return to Grasshopper, we're going to define a move vector, which is going to move this up in space, which is going to be a vector that has some z component because we want to move it in the z direction. So we're going to construct that vector. And we can do so in a number of ways. If we go to the Vector tab, we can construct it just like we constructed a point before with the x, y, and z. So this would be a perfectly legitimate way to do this, where I'm going to plug this in as my vector, and I'm going to create some sliders that control it. So I could move this up and down in the z. That's pretty much what I want. And in fact, now if I copy and paste these sliders, I can also move it in another direction. But in this case, because I know that I really only care about moving it in the z, this is really a matter of personal preference. I'm going to use the unit z vector, which also takes an input for its magnitude. So let's create another slider, and let's set its maximum value to like 5. In addition to being able to double click or right click and choose edit, you can also go to values and specify a max value. Let's set this to 5. Those control the same settings. I'm going to plug that in to the input to unit vector, and it's going to produce a vector, which we can see by hovering over the output, which is going to be 0, 0, whatever this number was, because this is the z direction and it goes x, y, z. Another habit that's really good to get into in Grasshopper is using panels to inspect the data that you're getting. So if you're not entirely sure what's coming out of some output, you can create a panel by clicking Panel. And these are really versatile components. I think I showed before you can double click them and add data into them. But like other components, they have both inputs and outputs. And if you supply some data into the input of a panel, it will actually display what that data is in as best a form it can. So I can see if I plug this in that I have a polyline, or I have a length of this polygon of 21.9. So if I change this, it's going to change the length. So this is a really good way to get a handle on what data is coming out of which outputs. So having created this variable vector, I'm going to plug it into the move, and now I can control how far it moves. One thing that is different from Rhino is that when we move some object, so if I have my polygon over here, and I move it from here to here, it doesn't keep a copy of the original. But you can see that in Grasshopper, we see both the original small polygon at the bottom and the moved one. And so, in fact, whenever you transform something, you're not actually getting rid of it. And part of the beauty of Grasshopper is that every step of every operation remains present. So this is the polygon before we moved it, and this is the polygon after we moved it. And if we want to get rid of it, we can't just like click on this and delete it because it's not selectable. If we delete the polygon that created it, we don't get a polygon downstream because this one actually depends on the first polygon. I just did Control Z to undo. This move depends on the polygon. It needs to know what to move. So in fact, you're building out a kind of sequence of instructions, and in many cases, those will be creating sort of intermediate or temporary geometry. So as I showed before, if we want to hide this, because we don't actually care about it anymore, it was only an intermediate step on the way to a moved copy, we can select it, right-click the canvas, and choose Preview Off. And now we only have these two. Okay, so now we want to loft between these two. Remember, in Rhino, we use the loft command, which asks for a list of curves to loft. We're going to do the same thing. Let's guess. Maybe there's a component called loft. If I double-click and type loft, lo and behold, there it is. There's a component that creates a lofted surface through a set of section curves. So if we want, we can also go get it from surface, freeform, and loft. And here you'll find other components that are used for creating freeform surfaces. So this one is orange, which tells us that it's missing some data. You can see when I hover over it, input parameter C failed to collect data. So we haven't seen this yet, I don't think. If a piece of data is missing, orange doesn't mean that anything necessarily went wrong. It just means it can't compute because there's something that it needs that it doesn't yet have. So loft, we already saw, creates a lofted surface through a set of section curves, and it expects section curves. And note here that it says curves as list. We'll be talking a lot about lists during this series. And so it wants those section curves, and it also wants some loft options. And so when I have my polygon in Rhino, and I have another one, and I loft them, this little window comes up where I can specify what kind of loft. This is where I specify my loft options. The loft component also lets me specify these by right-clicking and managing my loft options. Is it a closed loft? Is it a straight loft? Does it have to rebuild? And so on. So there is a lot of the same things back and forth between a command and a component. So we want to loft this polygon and this moved polygon. So if we plug in this polygon and we plug in this one, we have a problem, because whenever you input a new wire to a given input, it replaces the old one. Unless, as I mentioned briefly last time, you hold down the Shift key. So notice that the arrow changes to a green one on my cursor with a little plus. So if I hold that down and hit plus, now I've fed them both together. And why isn't it lofting? That's odd. Let's try this again. This is going to be a Andrew thinking on his feet moment, because I expected this to work. Let's just zoom to our geometry. All right, we're going to pause while I figure this out, and then I'll explain why this happened. All right, well, I'm not totally sure what happened there, because now it's working fine. I create a loft component. I plug in my polygon, and I hold down Shift while wiring from the moved polygon, and it lofts. If you were running into the same problem, try right-clicking the loft options input, the O, and making sure that this says straight to make it into a straight loft. But it should work for a normal loft as well, so I don't really know what happened there. But in any case, this should do the right thing. So we now have this surface geometry that we've created that spans between our little polygons. And you might say, oh my God, that was so much work compared to just doing it in Rhino. But the beauty of this is I now have parametric control over this whole thing. I can make the aperture really small. I can change the number of segments. So I can make it more rounded, or I can make it more angular. I can control the outer radius, and I can control the height. And you'll see that there's even more power than this in Grasshopper, in that if we wanted to make many instances of this with different parameters, we could do that all at once in Grasshopper without a whole lot more work than this. But we'll be covering that when we look at our list tutorial. So let's keep this one in mind, because I think we'll probably come back to this example a little bit later on. So that concludes this tutorial, and look forward to seeing you for the next one.